sees this distortion in the fabric of space and time, and it curves in response to it. Einstein predicted this.
There could be detailed images it's delivered have been among the most breathtaking pictures of the past year.
The James Webb Space Telescope was recently sent into orbit and is currently looking far into space. Astronomers are quickly analyzing breathtaking images of the distant universe, and what they have learned is simply unbelievable. Only 300 million years after the Big Bang, scientists have reported that a massive structure dating back billions of years has been discovered using a telescope. What is this enormous structure that scientists have discovered? What relevance does it have to us then? Join us as we explore how the James Webb Telescope just detected a huge structure older than the universe. NASA created the cutting-edge James Webb Space Telescope to look into the far reaches of the universe and back to the beginning of time, and it is already succeeding magnificently. Numerous candidates for what might be the most distant galaxy ever seen have been found in the months since Webb's first science of photos and data were made available to astronomers to work with. The abundance of galaxies visible in the distant cosmos may be seen in Webb's photos, which were taken just a few 100 million years after the Big Bang. 13.8 billion years ago, astronomers' ideas about the early universe have been disproven by the telescope's startlingly crisp images. We had in mind an idea of what galaxies at these distances would look like and how much detail we'd be able to see. But I think the reality is just kind of blowing our mind, says Johan Kardalper, an astronomer at the Rochester Institute of Technology in New York. James Webb Telescope's ability to detect infrared light and the expansion of the cosmos, which extends light to redder wavelengths, makes it a good tool for identifying galaxies that originated at the beginning of the universe's existence. Webb found numerous far-off galaxies in its initial observing campaigns, which began in June and are beyond the capabilities of other observatories like the Hubble Space Telescope. It suggests what many of us have been arguing, that there are galaxies out there beyond what we saw with Hubble, says Richard Ellis, an astronomer at University College London. At the cosmic dawn, some 250 million years after the Big Bang, when the first stars appeared and illuminated the universe, the age of the early galaxies began. The weak red blobs that Webb is starting to find are galaxies, which are collections of later generations of stars. Numerous previously unseen galaxies in the distant universe can be found in the Webb photos. There isn't much unoccupied area, according to Carter Talbot, which isn't filled with something. One study analyzed the rate at which stars originated in the early universe by combing through data from many of the far-off galaxy fields Webb has so far observed. It discovered 44 previously undiscovered galaxies that date as far back as 300 million years after the Big Bang. The discoveries demonstrate that there was a size of population of galaxies generating stars in the early universe when combined with 11 previously identified galaxies. The team led by Callum Donald of the University of Edinburgh concluded that the findings reaffirmed the great potential of impending larger programs to alter our understanding of the young universe. Many galaxies are vying for the title of the most distant. The stampede of research teams racing to find the farthest galaxy in the Webb data is possibly the most well-known rush of all of the contenders, which would surpass Hubble's previous record for the farthest galaxy, which dates to roughly 400 million years after the Big Bang, need to be confirmed by additional research. One candidate appeared in the Glass Webb survey, which also featured a second significantly closer galaxy in the same image. Astronomer Marco Castellano of Rome's National Institute for Astrophysics adds, the discovery of these two brilliant galaxies was definitely a surprise. He and his colleagues didn't anticipate seeing any galaxies that far away in this particular region of the sky. The two galaxies were discovered independently by a second team. The redshift scale, which quantifies how much a galaxy's light has been shifted to redder wavelengths, is used by astronomers to determine the distance of galaxies. The higher the redshift, the farther away the galaxy is. The redshift of the Glass candidate is approximately 13. However, the ArgZip preprint server was inundated with articles reporting even higher redshifts. On July 25, days after astronomers announced the discovery of the Glass galaxies, Rowan Naidu, an astronomer at the Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts, claims that this is simply the beginning of the beginning. One potential candidate was discovered in a survey dubbed SEERS, one of Webb's most well-known early investigations, with a redshift of 14. Stephen Finkelstein, the lead researcher for SEERS at the University of Texas at Austin, gave the object the name Macy's Galaxy in honor of his daughter. Two potential galaxies were discovered in a different study that examined the first deep field image from Webb, which U.S. President Joe Biden made public on July 11. These galaxies have a redshift of 16, which would place them only 250 million years after the Big Bang. Additionally, ArgZip papers makes assumptions about additional possibilities up to redshifts of 208. A surprising amount of early galaxies are complicated. Additionally, the James Webb Telescope's far-off galaxies are proving to have more structure than astronomers had anticipated. One analysis of Webb's first deep field image discovered a very high proportion of far-off galaxies with disk-like shapes. Astronomers had deduced from Hubble data that local galaxies like the Milky Way frequently exhibit regular formations like disks, while distant galaxies are more asymmetrical in their shapes. According to the notion, interactions with nearby galaxies more frequently led to distortions in early galaxies. But according to the Webb measurements, the number of far-off disk-shaped galaxies may be up to 10 times greater than previously believed. According to Alison Kirkpatrick, an astronomer at the University of Kansas in Lawrence, with the resolution of James Webb, we are able to observe that galaxies had disks considerably earlier than we thought they did. She said, "This is problematic since it goes against past theories of galaxy evolutions. We'll have to work that out," she said. Massive galaxies may have evolved earlier in the universe than previously thought, according to a preprint study. 7 large galaxies with red shifts between 7 and 10 have been discovered in this year's field, according to a team led by Ivo Lab at the Swinburne University of Technology in Melbourne, Australia. We infer that massive galaxy formation began extremely early in the history of the universe, and that the center portions of at least some massive galaxies were already in place in substantial part of 500 million years after the Big Bang, the researchers write. Additionally, research on galactic chemistry reveals that the Webb data present a rich and intricate picture. A study of the first deep-field photograph looked at the light coming from galaxies with a redshift of 5 or more. Spectral lines that show up at different light wavelengths are related to the chemical components of galaxies. It discovered an unexpected abundance of elements including oxygen. According to Kirkpatrick, the discovery that chemical enrichment is occurring in early galaxies will make us rethink the speed at which star formation occurs. Astronomers had previously believed that chemical enrichment in which stars feeds hydrogen and helium to form heavier elements took some time. Even a little bit later in the development of the universe, the James Webb Telescope continues to astonish us. One investigation focused on Webb's observations of the cosmic noon, which occurred about 3 billion years after the Big Bang. At this time, the universe's star creation reached its maximum and the most light was produced. Astronomer Rand Swiss from the University of California, Santa Cruz, compared Hubble and Webb photographs of the same galaxies taken at cosmic noon. Most of the big galaxies appeared substantially smaller than they did in Hubble photos at the infrared wavelengths that Webb detected. It might alter the way we think about how galaxy sizes fluctuate over time, according to Swiss. The Hubble investigations revealed that galaxies begin small and expand over time. But the Webb results suggest that Hubble didn't see everything, suggesting that galactic evolution may be more complex than previously thought. Astronomers are aware that there will be many changes in the year to come, with Webb only beginning its anticipated 20-year career. The spacing between the peaks of light waves can be used by scientists to estimate how old the light is. Since the Big Bang, the cosmos has been expanding, stretching out light into redder wavelengths that Webbed infrared detectors can detect. Scientists must now ascertain the light's chemical composition in order to confirm that some of them are from 13.5 billion years ago. With the James Webb Telescope in the sky right now, finding old galaxies should become much more common. The telescope has only been focused on a small portion of space, thus its full detecting potential hasn't even been unlocked yet.